Okay, pre-calculus or college algebra. We are beginning our unit, or well, our lesson on solving equations. Today we're going to work on linear and quadratic. When it says linear, that means x is to the first power. So if you look at all of these situations, the variable is to the first power. You don't have x squared or 1 over x or anything like that. Just to review, hopefully these should be review for you. 2x, we're going to distribute the negative 5x, plus 5 is equal to 3x plus 2. And combine like terms. I have a negative 3x plus 5 is equal to 3x plus 2. So I subtract the 3x over, I have negative 6x plus 5 is equal to 2. Subtract the 5, negative 6x is equal to negative 3. Divide by negative 6x is 1/2. If you wanted to plug it back in, that would verify your answer. In this situation, we add 6. 3 over 2x is equal to 27. To get rid of that fraction, we multiply by the reciprocal. X is 27 divided by 3 is 9 times 2 is 18. I'm one that really doesn't care for working with fractions. And so one thing you can do if you have fractions in an equation, because you have an equation, you can multiply through by a number and change the equation. I'm going to multiply through by 15. When I multiply it through by 15, that's going to cause the 3 and the 5 to disappear. 15 divided by 3 is 5, times 4 is 20. 15 times 12, let's see, 10 times 15 is 150, and then so we get 180 out of that. 15 divided by 5 is 3, times 2 is 6. So by multiplying through by 15, that's the new equation that we get. I now have 180 is equal to negative 14g. I divide by negative 14, 180 over negative 14, or negative 90 over 7 is equal to g. Similarly, I'm multiplying through by a certain number. You want to look at what do 2, 3, and 5 all multiply to. The answer in that situation is 30. They all multiply to 30. So we're going to go ahead and multiply through by 30. And you start, 30 divided by 5 is 6. Now distribute that 6 through the top. We get 18x plus 12. 30 divided by 3 is 10, times 1 is 10. 30 divided by 2 is 15, times 5 is 75. So we have 75x. 30 divided by 3 is 10, times 1 is 10. Now, all the fractions are gone. Combine like terms, 18x plus 2 equals 75x plus 10. Subtract that 75x over. And I get negative 57. X plus 2 equal to 18. Negative 57x is equal to 16. Finally divide. Oh, somehow that came in, I didn't think that was, somehow it came in 18 over there. Sorry, that was 10. And then we subtracted the 2 to get 8. Sorry about that. Is that right? Sorry about that, folks. So x is equal to negative 8 over 57. There you have it. Okay, as we flip it over, A lot of equations that we solve do not involve linear, but rather are higher degree, second power, third power, so on and so forth. I like to use something called the zero product property. Zero product property is based off of this idea. If A times B is equal to 0, then A or B must be 0. So the key is to write it as multiplication or factor. And once we write it as multiplication, something that's factored, then we can check out that 0 piece. So in this situation, it's not factored. So let's factor it right as multiplication. We have x minus 5 times x plus 3 is equal to 0. So this is kind of like our A, and this is like our B. So x minus 5 is equal to 0. X plus 3 is equal to 0. So you solve both of those, you get x is equal to -3 and 5. Next situation, you see it's not equal to 0. You have to make it equal to 0. 6x squared minus x minus 5 is equal to 0. Now factor. Let's see if we can figure this one out. I think in 6x and x, thinking 5 and 1. This is going to have to be negative here. We're going to have positive there. Does that give me positive 5x, negative 6x? I do get the negative x in the middle. Solve both of those, and you get x is equal to negative 5 over 6 and 1. Next one, we begin by factoring out an x. It's already equal to 0. 4x squared minus 1. Now we have the difference of two squares. That will give me 0. That will give me 1/2. That will give me negative 1/2. Again, 0 out the equation. Then write it as multiplication. I'm going to write it as plus minus there. So I have, as I go ahead, and I'm going to use a grouping option here. X squared minus, x squared times x minus 2. Factor out a negative 1. And you're left with positive x minus 2. Now I can factor out an x minus 2. Left with x squared minus 1. X minus 2 times x minus 1 times x plus 1. So your solutions are negative 1, positive 1, and 2. 3 solutions. Solve the following by completing the square. When you complete the square, there are certain polynomials that are perfect squares. For example, x squared minus 10x plus 25 is a perfect square. It factors to x minus 5 squared. X squared plus 6x plus 9. That's a perfect square, factors to x plus 3 quantity squared. X squared, let's see, minus 2x plus 1. That's a perfect square because it factors x minus 1 squared. So perfect squares have this piece in common. Okay, first of all, the 25, you can see the square root is 5, and then this number is double that number. So square root of 9 is 3, doubled is 6. Square root of 1 is 1, doubled is 2. So you can see the relationship that exists there. So what we want to do is we want to take these equations, and instead of using the zero product property, we're going to complete the square. So I have x squared minus 2x, and then I add the 5 over to the other side. I have 5. Now what I do is I go to complete the square. The way we complete the square is we take the middle number, which is 2, and we divide it by 2, and then we square it. and that will give us 1. So if we add 1 to that side, we're going to add 1 to this side. This factors down now to x minus 1 quantity squared is equal to 6. Now we take a square root. Because it says squared here, we have to list 2 solutions. So we list a plus or a minus 6, square root of 6, excuse me. When we take square root of that, we're left with x minus 1 is equal to plus or minus the square root of 6. So because we took the square root of something that was squared, you have to list positive and negative solutions. Add the 1 to both sides, x is equal to 1 plus or minus the root of 6. And that is my solution. In the next situation, you can see you have a 2 in front. And we can deal with this very simply by dividing through by 2. And that works out very nicely because, if you notice, 0 divided by 2 is 0. I can move the 1/2 over. X squared plus x is equal to 1/2 by adding that over. So now I look at the number in front of x, it's 1. I divide it by 2, and then I square it. And that tells me what I do to complete the square. I add 1/4. If I add 1/4 to that side, I should add 1/4 to this side. This is a perfect square. X plus 1/2 quantity squared is equal to 1/2 plus 1/4 is 3/4. Go ahead and take square root of both sides. And I get x plus 1/2 is equal to plus or minus the root of 3 over 2. Now we subtract the 1/2. X is equal to negative 1/2 plus or minus the root of 3 over 2. Or you could just write it as negative 1 plus or minus the root of 3 all over 2, as they do have the same denominator. And that's your result. So you have a couple different pieces here. Solving linear equations, we dealt with fractions. We also dealt with zero product property. And then we also dealt with solving by completing the square. One thing I will remind you of as well is that when you're solving using quadratics, you can factor, you can complete the square, but you also have this gem, which is the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. And I know that that looks cumbersome. You're going to use it a lot, so learn to love it. It's a good thing to use. We use that when solving ax squared plus bx plus c is equal to 0. You can always use the quadratic formula as well. So go ahead. You can get started on that. Good luck. I hope it goes very well.